Good day everyone, we are from Group 5 and today we are going to present the experiment Bourdon tube pressure gauge. And I am the group leader Unyu Jing and I have the members Farah Elena, Kohui and Ranjit. Next, I will be presenting the theory. So the first one is Bourdon tube pressure gauge. It is a mechanical pressure measuring instrument that reads the pressure without requiring any electrical power that generally used for the measurement of pressure from 0.6 to 70,000 bar. The Bourdon tube works on a simple principle that a bent tube will change its shape when exposed to variation of internal and external pressure. As pressure is applied internally, the tube straightens and returns to its original form. When the pressure is released, the tip of the tube moves with the internal pressure change and is easily converted with a pointer onto a scale. A connector link is used to transfer the tip movement to the gear movement sector. The pointer is rotated through a tooth pinion by the gear sector. And the second part of the theory will be the deadweight tester. It is a calibration standard that uses the principle of a pressure balance to calibrate pressure measuring instruments. Deadweight tester use calibrated weight to apply known pressures to a device under test for a simple and cost-effective solution that covers a wide range of pressure calibrations. We put the weight on the weight stand of deadweight tester. Putting weight is reference weight, which is to be calibrated, and further we apply pressure by moving piston. When applied pressure, weight will be 0. And the third part of the theory is the equation. We can apply Pascal principle to our Bourdon tube pressure gauge setup, as it is also a hydraulic system, as we can calculate the theoretical value for pressure from weight of dead weight and the area of piston contacted with fluid. And the equation will be P equals to F over A and F equals to mg, where P is the theoretical pressure in cylinder, F is the loaded weight, and A is the area of piston.
Hi, Assalamualaikum. I am Nur Elena binti Kamar Zaman. So, for this experiment laboratory 6, I will start by discussing the summary report part. So, first of all, the purpose, or we could say the aim of this experiment, is to calibrate a Bourdon tube pressure using dead weights. In this experiment, in order to get the gauge pressure data, we load and unload the dead weights by 0.5 kg. During this experiment, there is a caution step to get an accurate result. The caution step is to rotate the piston slowly in order to remove the air bubble from the cylinder. However, there is still some experimental error, therefore we still could get the percentage error for both loading and unloading dead weights. To get the percentage error for both loading and unloading dead weights experiment is by comparing the theoretical pressure and the experimental gauge pressure. Thus, we could obtain the accuracy of Bourdon tube pressure gauge. Next, I'll discuss on the results part. In this result, there is mass in unit kilogram with the mass added by 0.5 kilogram and the total mass. There is also the theoretical pressure and experimental pressure in the unit kPa. For experimental pressure, there is loading dead weights and unloading dead weights. There is 3 experiment readings to get the best experimental value, which is the average that we have calculated by adding all 3 readings and divided by 3. And lastly, we have calculated the percentage error for both loading and unloading. So that is all for the results part. I'll pass to the next presenter.
My name is Kohui, and now I will continue with the discussion part question 1, where the question is to find the percentage of the relative error for the theoretical and the measure pressure gauge. So for part A, we know that the piston of the known area is loaded by the known weight. Therefore, the theoretical pressures in the cylinder is equals to the known weight divided by the known area and is in kn per meter square unit. And from the video, we have the data of the mass of the plungers and platform is equals to 1 kg and the piston error is equals to 3.1731 times 10 to power of negative 4 meter square. And for the calibration constant is equals to the total mass in kg times 30.92 and is in km per meter square unit. And for the gravity, we take it as 9.81 meter per s square. So at first, we need to find the true pressures that exerted by the plungers and platform only. So from the formula given where the theoretical pressure is equals to the known weight divided by the areas, and we have the mass is equals to 1 kg, and we need to convert it into Newton. So 1 times 9.81 newtons and divide by the area, where the area is 3.1731 times 10 to the power of negative 4 meter square. And we need to make sure the unit in the upside and downside is same, so we need to divide 1000 and we'll get 30.91 kn per meter square. And then we continue to find the true pressures that exerted by the total mass, where it is 0.5 kg of the mass added. So from the formula given, we also calculate with the same method and we'll get the theoretical pressures for 0.5 mass added is equals to 46.4 km per meter square. And now we need to find the measure pressures that we obtained from the reading of the Bourdon tube pressure gauge. So for the 0.5 kg of the mass added, we take the average reading of the calibrated pressures for loading 1, and then we'll get 30.3 km per meter cubes. And then we calculate for the average reading of the calibrated pressures for the unloading 1, we'll get 40 kN per meter cubes. So from here, we have the theoretical value and also the measure value, and then we can find the percentage error. So for the percentage error of the loading 1, the percentage error is equal to the experimental value minus the actual value divide the actual value and times 100%. So from here, for the loading 1, we'll get 30.3 minus 46.4 and divide by 46.4 times 100%. We'll get 34.7% of the percentage error for the loading 1. And for the unloading 1, we'll get 13.8%. And we use the same methods to find for the rest value.
Next, I will present the second question of the discussion, which source of error and method to minimize the error. The first error is the parallax error. Parallax error is one of the most common errors. This happened when observer did not take the reading with eyes perpendicular to the scale. To avoid this error, observer should make sure that the eyes are perpendicular with the readings, and it is encouraged to repeat the experiment for a few times and take the average reading. And the second one is presence of air bubbles inside the tube. Air bubbles trapped inside the system causes our reading to deviate from the theoretical value. Hence, it is advised to give enough time to release all the bubbles inside at the beginning of the experiment, so there is sufficient time for all the air bubbles trapped to escape the system. And the third one is friction in deadweight calibrator. The deadweight calibrator might work slowly in changing pressure and cause the friction to occur. So it is advised that the weight is loaded slowly to avoid friction. And the last error is leakage of water from the piston cylinder system. Leakage of water from the piston cylinder system while the experiment is conducted will reduce the amount of effective pressure transfer to the Bourdon tube. To reduce this error, experimenter is suggested to make sure the apparatus is in well condition.
Hello everyone, I'm Ranjit. So here I'm going to discuss about question number 3, which is about repeatability and accuracy of this equipment. So for repeatability, the equipment was displayed by the repeated times under the same conditions, such as the mass added by each time. This is to get average reading because the Bourdon gauge can be regarded as a device which is sensitive to surroundings, especially the temperature fluctuation. From this experiment, the highest percentage error by comparing both experimental and actual result is 35.3%. This indicates that the experiment conducted might experience some inevitable errors or fluctuation. For accuracy, The average reading is obtained by repeating the same experiment for several times to get the most accurate reading with the repeated procedures. When the mass was added to the piston, the dead weight pressure gauge calibration responds slowly and results in the delaying which is corresponding to the changes of pressure as well as the friction. The next, although the accuracy and quality of modern tube pressure gauge has not reached 100%, by repeating the same experiment for a few times to get the average reading, the result obtained would be more accurate and more reliable. So the next part is conclusion. So in conclusion, the value of percentage error for loading is in range of 13.7 to 25.2, while the value of percentage error for unloading is in range of 0.6 to 35.3. This is due to some experimental error, which is a combination systematic and spontaneous errors that happen during the experiment. Thus, we must repeat the experiment for several times to find an accurate estimated value. That's all from us. Thank you.